Antelope Canyon Trail Run. It was fantastic. This pottery was made by a novel. It's amazing. And that was my my trophy for finishing the race. So it was pretty cool. Okay, let's throw out some algebra. Let's just do one step. Okay? I'm gonna do 4 one-step equations. So here's example 1. Example 2 we'll scoot over here. Example 3 will be down here. And example 4 will... Okay, so let's start here. So where's our number? Our variable, rather. We want to know what this is. Something plus 4 is 9. Now, the reality is I've got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Something plus 4 is 9. What was the something? 5. 1, 2, 3, 4, 5, right? We don't need algebra for that. But we're not just simply problem solving this. We're practicing the method so we can do complicated things. Okay? It's like if someone says, well, I can dribble standing here with my right hand. That's awesome. But when someone's coming at you trying to steal the ball from you, can you switch it to your left and go behind the back and dribble around and be able to pass it off to your teammate or shoot with the wrong hand? Like, come on. That's a single skill in the larger idea. All right? Okay. So we're going to call this, I'm stealing this from a student who told me from a different teacher. I have no idea where it came up with, the balance line. All right? You can do this however you want. I have found the easiest way to make equations clear to the reader, which would be a teacher in this instance, or as you get up in math, a colleague, right? As you work down and you keep the equal sign literally over itself the whole time so we can see what's going on, right? So we have our variable plus 4. So how do we invert 4 or invert addition? Subtract it. So we subtract 4. Now you'll notice even here, -4 is equal to -4. That's the whole point. So this thing started equal. These operations on both sides are equal. And so then what you get going down remains equal. Well, over here you have n. 4 minus 4 becomes the identity, 0. The identity under addition, 0. So we don't write it. Equals 9 minus 4 is 5. That's the whole point. And we're getting a little glare. N equals 5. If I turn this off, yeah, it's too dark. Lighting problems, right? So just be clear in your presentation also, okay? You are making an argument. Let's go to example 2. And maybe I'll do my my leaning idea. Don't miss me too much. Can we even see it? I don't know. Well, here's our balance line, right? The inverse of subtraction is addition. We need to add 8, right? On this side, 8 minus 8, or -8 plus 8 is the identity. So it's 0. We don't write that though. N equals 3 plus 8. We can use the number line if we need to. 11. Okay? How are we feeling about that one? The last one is going to be hard to do. Problem number 4. Does that make sense? What is happening? What is happening right there? If I don't have anything written, again, there's a lot of implications in math. If there's nothing written in terms of an operation and you have a number butted up against a letter, what operation is that? Okay, these are implicit things you need to know. This is multiplication. The inverse of multiplication is division, right? So we are going to, don't forget our balance line. Divide by 3. Remember, this is division. Fractions are implicit division. Divide by 3. Okay? Now, visually you might go, what the what? Because you can take these both simply. Remember, we had a lesson, I believe, right, on simplifying fractions. I hope I uploaded that. Maybe I didn't. I'll have to upload it later. So many things to keep track of. 3 over 3 is 1. That is the identity under multiplication. We don't usually write it. We just end up with our W over here. 12 divided by 3 is 4. Okay? Now, If for some reason 12 didn't divide into 3 evenly, you can leave it that way because 12 over 3, these fractions, they're numbers. They're not integers, right? What number set do they belong to? You remember? They're rational. They're ratios. W is 4. I wrote that poorly. All right, let's look at our last one in the corner. What operation is this? It's division, right? So the inverse of division is multiplication. Now, it gets a little weird. I feel like getting rid of this for a second. But because I've been trying to show you how to work down, and you still are working down, but it's easier to see actually if you just put the multiplication right next to it. Because this is like 5 over 1. And those cancel. Anything over itself is 1, which is what we want here. So you end up with x equals, and then 2 times 5 is 10. And then that's it. Okay? Done and done and done. I'm going to do some multi-step examples. Math.